A very good afternoon, students. In this video, we will be discussing the insertion sort algorithm. In insertion sort, the crux is that we try to insert each element in its proper position in the first half of the array. How we proceed is, let us look at an example. Suppose we have an element 1, element 3 and element 0. These are the three elements that we have. Now we have to sort this array. So how we will begin? We will assume that 1 is already sorted and then we will try to place 3 with respect to its value with 1. So what we will do, we will compare 3 with 1. Now since 3 is larger than 1, we will not do anything. We will keep 3 where it is. Now the first two elements are already sorted. Then we look at the third element. Now this third element, it can remain where it is, or it can take the position of the third element, second element, or it can take the position of the first element. How we will decide where it will go? We will compare this element with the element preceding it. So 3 will be compared with 0. Now since 3 is larger, we will shift 3 in position of 0. And now this position will become vacant. Then we will compare this 0 with 1. Now since 1 is larger than this 0, so we will shift 1 here and this position will be made vacant. And since there are no more elements towards the left, so we will copy this 0 here and 0 will become the first element of the array, and as we can see, the list is sorted. So what we do, we assume the first element is already sorted, then we try to place the second element with respect to first, and after the first two are sorted, we try to find the position of the third element with respect to first two. Then if there are more elements, we will know that the first three elements are already sorted, and then we will try to place the fourth element, whether it will remain where it is, it will come between 1 and 3, between 0 and 1, or before 0. So this way we proceed in insertion sort. Now let us look at the algorithm. Now in the algorithm, we will go from the second element till the nth element, because it will take the values from 2, because first element we know is already sorted. So we have to sort from 2 till nth elements. Now j will be I minus 1, which is the preceding element to I. We are trying to find the position of the ith element, and all the elements before I are assumed to be sorted. So the highest index less than I, which is I minus 1, will be stored in j. Then we take the target to be a of I, because it is the target whose position we want to find out. Now in this while loop, what we will do, if the a of j, the element preceding the target, is more than the target, then what we will do, we will shift the jth element in j plus 1 position. So the jth element is shifted into j plus 1 position, and then j is decremented by 1. And then we compare the new a of j with the target, and if this new value is also larger, then we will shift. If it is not large, it is equal, or it is lesser, then we will break out of this loop. And what we will do here, we will place in the a of j plus 1 the target element, because this is the correct position with respect to the remaining elements in the first half of the array. Let us look at an example. Now in this array, we have an index from 1 to 5. So this is the element which is already sorted. A of I will be 3 and target will be 3 and j will be the fifth element. Now we will compare 3 with 5. Now since 5 is large than 3, we will keep 3 where it is. Then we will move ahead and now I will become 3 and it will point to element 2. So target is the second 2 element. Now we will compare 2 with 5. Now since 5 is larger than 2, we will shift 5 towards the right and this position will become vacant. Then we will compare 2 with 3. Since 3 is large, we will shift 3 and this position will become vacant and we will copy 2 into this position. Now 2, 3, 5 are already sorted. We will consider for the target 7. Now 7 is compared with 5. It is already in its proper position. So we will not do anything. Now target will become the fifth element, which is 1. 1 is compared with 7. 7 is larger than 1. So we will shift 7 towards the right. And then we will compare the first 1 with 5. 5 is larger. So we will shift 5. Then with 3 we will compare. We'll shift 3. With 2 we will compare. We'll shift 2. And the first position will become vacant. And we will place 1 here. And the array is sorted. I hope the algorithm is clear to you. If you like the video, like it, share it, and subscribe to the channel. Thank you.